Hi and welcome to challenge 4 of this series. In this challenge, our task is to come up with the character frequency of a given input. So let's really try to understand what it is that we want to do. We have an input string like this. It could be anything. It doesn't matter what the input string is. What matters is, based on what that is, we need to count the frequency or how often a character appears within that string. And what do I mean by that? So I'm going to give you two examples. One is P. We need to count how many P's there are within the string. And if I take a look at this, we can see there is just one. And a second example would be the R. Now, if I take a look at programming languages, how many R's are there? So we can see we have this one R right here, and we have the other one right there. So there are two R's. And our output basically should be something like this. So it looks like an object because it is actually an object. The reason that it is an object is because we grab every character and we give it a value. So there are two things that we need to consider for every individual letter. In other words, in programming words, that is a key value pair. And the way we represent that is usually using an object. So we need to come up with this object that is basically called a frequency map of the string. So let's jump into JavaScript. That's the first language that we're going to attempt to solve this in. The first thing that I'm going to do here is I'm going to create some sort of a variable that is going to hold my input string. And I'm going to call it input stir. Now, the input string could be anything. This is just an example. Now, once the challenge is solved, we should be able to pass anything in here and that should work. Now, this is our input string. We need to have our frequency map as well. I'm going to create that. I'm going to say const. I could go with let, but since this is an object, I could get away with const. Frequency. And you could call this whatever you want. I'm just going to call it frequency, and there is an E missing. Now, let's see how we can actually come up with this, with a way to solve this and populate our frequency. So when it comes to our input string, we want to take a look at each of its characters or each of its consisting letters individually. It means we want to iterate over that. So I could basically say for char or character of input string, what do I want to do? So this char right here, in each iteration, this is going to select one of these characters. Now we're going to get started with P. Now let's say this is P. Once we start counting the character, the first count is always going to be 0, because once we start with this, we say, okay, is there any other P? No, this is the first P. So if there is no other P, that means the P count is 0, and then we increment it from 0 to 1. So we need to basically handle that. So if we take a look at our frequency and we try to populate our frequency array using our char count, keep in mind, we want to pass in the string, which is that specific character, as well as its value. So this is how we populate that. But if this doesn't exist, that means the count is actually 0. So let's handle that as well. I'm going to set the char to 0. Now, if the count is not 0, that means there is another character in there that looks like this character. So we take a look at P. P doesn't exist at the first instance, so we set it to 0. But then once we get to the first instance of the P, it means there is one P. And in that scenario, we just grab our frequency, and for that specific character, we increment it by 1. And that's it. That's the only thing we need to do here. Again, if the character doesn't exist, and that's before starting the count, we set the count to 0, because the count should have an initial point, and this initial point 0 is where we increment the count for that. If we don't pass in 0, what do we add 1 to? We add 1 to 0, all right? That's why we need this initial count. Let's grab our console log. console.log, and I'm going to pass in our frequency. Now keep in mind, we want to print the object. We don't want to get any specific letter from there. And now let's save this. Let's run this node A. And there we go. This is what we got. So I'm going to bring this up. And this is exactly what we got. So we get an object that has all of the characters. And in front of each of the character, there is the frequency for that specific character. And we can just check a few of them. We can take a look at R. There are 2 R's. What about G? So we have 2 G's here, and then we have 2 G's here. And there we go. We got 4 G's. What about A's? 1 A, 2, and 3 A's. And there we go. We got 3 A's. And we can see that it actually works. We could change this input string to something else just for testing. I could pass in 4 A's, 3 B's, 2 C's, and 1 D. And now let's run this again. And there we go. We got a 4B3C2D1. So this is the solution for JavaScript. TypeScript solution is always going to be almost similar to that of JavaScript. And we're going to leverage type safety of TypeScript, but the logic of this is going to be the same as JavaScript. So what I could do is I could just copy this entire thing, put it right here, and I can walk you through this, how this actually is going to be changed for TypeScript. Now for TypeScript, what I want to do is I want to actually come up with some sort of a type for my frequency map. And the reason that I want this is, you can see it's already yelling at me. So let's take a look at why our native JavaScript code doesn't actually run without any errors inside of TypeScript. So if I hover on this, it says element implicitly has an any type because the expression of type string cannot be used to index type this. No index signature with a parameter of string was found in this. So it's suggesting to us that we didn't use any index signature. An index signature, in short, in TypeScript, it gives us a flexible type for an object, in which the key type could be anything, as well as the value type could be anything. Now, that's an index signature. Now, if you're using an interface or a type alias, the key has to be that specific key that you have used within that interface or type. But in an index signature, it could be anything, as long as it follows some certain rules. Now, I'm not going to jump into index signature because there is actually a simpler solution to this. And that is, we could use a record type. Now, a record type is a type that maps the keys of an object to the value of that object. It is written like this. I believe we have talked about this in the data types lesson of this series when we talked about TypeScript. Now, the key type, I want it to be string, but the value type, I want it to be number. Now, keep in mind, I'm not specifying what keys there should be. I'm specifying what the type of the key is. So it's almost like an index signature, but it's so much easier than an index signature. And you might be asking, okay, why aren't you using like interfaces? When it comes to an interface in TypeScript, what should I write in here? I mean, an interface requires a key, and then on that key, like name, you specify a type like string. This interface, let's say, person, whatever. Now, on this name, you specify a type. So the name has to be of type string. You could have an age. The age should be or must be of type number. But I don't know what the key is. It's not like I don't know what the type is. I know what this is. I don't know what this is because the string is going to be different. It is programming languages. It could be A, B, C, D. It could be anything. Now you can see in A, B, C, D, I don't have any R. I don't have any M, N, G, I, L, whatever, U. I don't have any of those. So when it comes to, you need to be able to differentiate between these. When it comes to type aliases and interfaces, they require fixed keys, but the type of the value, you can change it to whatever it is, depending on that key. But in record, you don't fix the key. You say, okay, the key has to be of type string, and the value has to be of type number. Now the string could be literally anything. It doesn't have to be age, it doesn't have to be name, it could be anything. And that's why it's appropriate for us to use a record type, because we don't know what the key, we know the type of the key, we don't know the actual key itself, the literal key. We don't know what that is. And aside from this, everything is going to stay the same. We have already talked about this logic. If there is no count, and at the first instance, there is no count, we need to initialize the count to something so we can add on to this thing. We don't initialize it to a string because you don't add to a string. You add numbers together, not strings together. So I'm going to say TSC. Let's just compile this first. And there we go. And after that, I could say node. Let's run this. And there we go. We get the same result. Now, if I were to bring this up, the second input, let's run TSC. And after that, node. And there we go. We got 4 A's, 3 B's, 2 C's, and 1 D. Now that the solution for TypeScript is done, let's jump into Python. Now, Python and JavaScript, they go hand in hand. So the solution that is going to work for JavaScript, most of the times it's going to work for Python. Or what I do is I try to make sure that if these languages have something similar, then I'm just going to go with that. Now, when it comes to Python, we still need to have some sort of an input string. Now, I just had an idea. I could copy all of this from JavaScript, put it inside of Python, and just change the syntax. And I could show you how that works. So in Python, we don't have this const. We don't have this. We don't have this const. So let me get rid of this. Let's get rid of that. We have this input string. Let's change it to the Pythonic way. So I'm going to say _stir. Now I'm going to comment out the below one. There we go. We have our input string, which is programming. There we go. So we have our frequency. Let me remove the first space. There we go. Now we still have this, which is a dictionary in Python, and we have our input string. So both of them are the same. The only thing we did was we got rid of our initializer for variables, that variable declaration word like const or let or var. So here we have our frequency map. After that, we need to have our loop so we can loop over that. Now in Python, we don't have a for of loop, and we don't have all of these parentheses and curly brackets. We have what do we have? We have colon and then indentation. So here I'm going to say for char, we don't have of, but we do have in. We don't have this input string. Let me put it right there. There we go. So for every character inside of the input string, if it doesn't exist, now take a look at this. This is going to be really more readable in Python. I'm going to say if character is char or character is not in frequency, then do what? Then set that to a value of 0. Now there is an error because we didn't provide our colon. And there we go. You can see Python syntax is so much sweeter. Otherwise, we want to do this. We want to increment this. Now this is invalid syntax in Python. So what we need to do is we need to say this. So if it doesn't exist, we add it, we initialize it to 0, but if it exists, we increase the count by 1. And now we no longer have console log, we have print, the more appropriate method for it. And in Python, it's very important to keep in mind the indentation. So if this frequency was one step indented, that would put it inside the block of this if statement. Once I de-indent it or bring it back, this puts it outside the if statement, but still inside of my for loop. All right, see, it's inside of the for loop. And now let's run this. Let's clear this. Clear Python file C and run, and there we go. That's what we get. And this is exactly the output that we wanted. We have 2 R's, we have 4 G's, 3 A's, And there we go. And we could take a look at our second input string. Let's run it. Okay, it's just one step indented. Clear this and run it again. And there we go. Perfect. So the Python solution is done, and we're going to jump into Go. And there is not going to be any copy pasting in Go. Now, when it comes to Go, there are some things that we are going to do no matter what. We need to import our main package. I've already talked about this several times. We need to define the entry point for this application or for this program, which is our main function. Now, much like TypeScript, JavaScript, Python, we need to have some sort of a variable to hold our input string. I could call it input stir, and I could use the short variable declaration. I'm going to pass in our programming right here. And after this, what I want to do is I want to create some sort of a data structure that looks like a Python dictionary or a JavaScript object. And for that, I'm going to use a map. So I could call this frequency, and that would be exactly the same as the other languages. So we have this frequency, and the type of this, I'm going to type annotate it first, and then we're going to see how we can actually create this. So this is going to be a map. Now the map requires a type for a string, which is a type for a key, which is of type string. But then what type should be the value? That's going to be the type integer. We need to initialize this, and I'm going to use our make method to initialize this. And we can already see that it is going to tell it for us. So it is going to initialize a map that has a type of string for keys and a type of number for values. Now, we need to iterate over our input string, much like previous languages, and we need to take a look at each string individually. Now, when we iterate in in Go, we have this underscore, which is the blank identifier. And the reason that we pass it here is because this iteration gives us indexes or indices. We don't need them. We are just talking about characters. Let me just use short variable declaration here as well. We're going to grab our range keyword, which is going to iterate over our input string. And then in each iteration, what do we want to get? Now, keep in mind, once you're iterating over this input string, ch or char, that's actually a rune. That's the reason for that is so we can iterate over our string. Now, once we have a rune, we need to convert it into a string before putting it inside of our frequency map. So I am going to create a variable called char, use short variable declaration, and I'm going to grab my string method and I'm going to pass in ch in there. So every ch is now a character of type string, and now I can put it within my frequency map. Now we select our frequency map and we want to populate it by every instance of the char. Now, what Go does for us is it's going to automatically initialize this char to a value of 0 if it doesn't exist. So we don't have to worry about initializing it to 0 if it doesn't exist. But if it does exist, we are going to increment the count by 1. So I'm going to say +1. And let me just try to explain this a little bit better. So here what we do is we try to access the current value associated with the char key inside of our frequency map. And then after that, what we do is we increment that by 1. And once we increment it by 1, we reassign this to our map. We reassign it back to our map. And the reason that we do this is because in Go, maps do not have a built-in increment operator. So what we do is we fetch, and then we increment, and then we reassign using this equality operator or assignment, using this assignment operator. This is not the equality. All right. And finally, what we need to do is we need to go ahead and print this. So let me just bring back my cursor. Make sure to be still within the main package. So in here, I'm going to say fmt dot, where is our print line? And I'm going to pass in our frequency map right there. Go run d-tab, enter, and let's wait for it for a few seconds. And there we go. This is what we got. Now, it doesn't look like the syntax that we had here. Like we don't have these curly braces. That's because of the Go language, but nonetheless, our result is going to be the same thing. We have 4 G's, we have 3 A's, we have, where is our 2 R's right here? So the result is the same. And that is it for the Go solution. Let's jump in here. And I'm going to jump into our Rust solution. Now, the Rust one is going to go almost the same as the Go solution. The first thing that we need to do is we need to create our main entry point for this application or for this program. And in here, I could use an own string or a string slice. I mean, I'm just going to go ahead and I'm going to go with a string slice. And this is going to be programming. Let me just grab it. Whoops. Programming languages. And after this, now we need to create our frequency, remember? So I'm going to say let frequency. Now, this is going to change. When something changes in Rust, you need to give it the mut keyword. So this is like changeable. And what should be the type for this one? We could use a map type for this one. It's actually called hash map. The hash map specifies, you could think of it like the record type for TypeScript. For record type in TypeScript, we provided the type for the key and the type for the value. The type for the key is going to be char, which is of type string. The type for the value could be any integer that you can think of. I'm just going to say i32. Now, we need to initialize it to a new hash map. I'm going to say hash map new, and there we go. So we just created a new empty frequency object or frequency map with the type of hash map. Now, after that, what we need to do is we need to iterate over each of these characters, and subsequently we need to increment the value of that if that character exists. If it doesn't exist, we are going to initialize it to 0. So I'm going to say for ch character in input string. Now, we're going to use the chars method to get every individual character from the string, and this is going to get for us the spaces as well. That's really important. And the ch is going to iterate over all of them. Let's see in each iteration, what do we want to do? Well, in each iteration, we want to grab our frequency and we want to pass in some entries into that frequency. What is every entry? That's that ch or character for that entry. Now, what if the entry doesn't exist? We are going to say or insert 0. If the character doesn't exist, we're going to insert 0. But if it exists, we need to increment it by 1. Now, here is something that's actually missing inside of our code, and that's something that's called dereferencing. The reason that we need these dereferencing is because the entry method for us, it returns a mutable reference to that value inside of our frequency map. To actually modify that value basically means if there is one R, the R is going to be 0. If there is one R, you're going to increment that by 1. So you're actually modifying that value. To be able to modify it, you need to dereference your frequency by adding a star or an asterisk in there. So once you dereference it, then you can modify that frequency map. And that's the last thing that you need to keep in mind. And after this, make sure you are still within the main function, and we are basically going to call our print method. But before that, we need to import our hash map from the standard library. So I'm going to say use std collections, and then from there we're going to grab the hash map. Let's terminate that line. I'm going to terminate this one as well, and this one, and let's come right here, terminate this one as well. And in here, let's grab our macro, print line, there we go. Now, this hash map, this is actually a more complex type. we cannot use our displayed specifier to show this. We need to take a look at something that's called a debug specifier, because this is a more complex type. So this is going to be, this placeholder is called the debug specifier or debug formatting specifier. That's the name of it. The reason we use it is so we can print it in a way that's readable. And let's save this. Let me just indent this a little bit. Let's save that. Let's see if there are any errors. We're going to fix that. Enter. There we go. No errors. That's very good. Now, the only thing remaining is we need to run our executable, and we should see the result. There we go. We could take a look at the G's, the A's, as well as the R's. Where are the R's? There we go, right here. And now let me change this to something else for testing. There we go. Let's save that. Let's compile this, convert it to executable, run the executable again, and there we go. 4 A's, 1 D, 2 C, and 3 B. And that's it for this video and for this challenge. I hope you enjoyed it, and see you in the next one.